more or less ready to start. If you're at the utilizing mold tools and other techniques for better mold design, you're at the right place. My name's Andy Hall, and this is my third attempt at SolidWorks World to give this presentation, and I'm excited to be here. So how many people here do mold design or are mold designers, work in a mold shop? I used to, but no, it's good to see. This is something I've been working with off and on for more or less the last 10 years, just using SolidWorks in general to design injection mold. I started off in about 12 years ago, 13 years ago, doing in a mold shop, and worked there for 6 years. And then I went over to the reseller channel for about another 4.5, 5 years before going back to a mold shop where I worked designing and manufacturing model trains. That was a fun job. I could tell people that I was an engineer for a model train company. That was fun to say. But then about 6 months ago, I left the model train industry to go back to sort of the software. And right now I'm an application engineer for one of the SolidWorks partner products, CamWorks. So today I'm focusing on the SolidWorks tools for the mold tools. And it's quite at least I've prepared quite a bit of material, but I put this as sort of more of a, not an advanced, intermediate type session, just because of what I consider the prerequisites of what you sort of got to be familiar with in the when using the mold tools, just what's going on behind the scenes. Of course, I show basic part modeling and then knowing what surfaces and multi-body part modeling. And if you go downstream and you're actually building a mold base, knowing a little bit about assemblies and how they work. And then, some of the various components. And I even get in a little bit of weldment functionality. That's how I've sort of done ejector pins. And so that's why I have that on the list. So just sort of a basic familiarity with some of the tools here. Today we're going to, for the bulk of the session here, we're going to talk about the mold tools themselves and just go through a workflow, starting with just the basic components, and then I'll give you some examples of some more advanced techniques of getting shut-off surfaces and parting surfaces, and a little bit of electrode design. Towards the end, we'll take it to the next step and work in assembly mode and do mold-based design. And if we have time, which we might, there's a good chance we'll get into some other techniques of mold design using the cavity tool in sort of an assembly. So one thing that I'm not going to really touch on this, other than this one slide, is the new SolidWorks plastics tool. Is there anybody here who uses it or has played around with it? Yeah, right there. Yeah, I grabbed some screenshots just to show that it's there, and I actually I was on the flight over here, and I was sitting by someone who is a mold designer for a medical company, and they say they use this all the time, or not this, or some mold flow type software too. And he's just a designer, but he uses it for gate location and some other basic things. And so I think it's a very useful tool if you have a chance to use it. I know that at the model train company where I was at, we always had a problem filling molds. We have 50, 60 little tiny parts that we're putting on the same mold that are different sizes, and trying to balance that, and having extra software that would help us design that would have saved a lot of time and a lot of money, a lot of effort on our processor's part. So there's a lot of use out of that. And if you happen to have that available to you. That's a great thing to take advantage of. However, today I'm not going to really go into that. I am going to go into the actual mold tools as shown by that, those 5 icons on that toolbar. And just show just a simple process, workflow of how to work for this wonderful assembly or product I invented a few years ago that I never got made because it didn't have any internal components. Is my vertical pencil sharpener, and there's a plastic housing on the top. And that's the part I'm going to start working with. So we're going to get right into it, and I'll just flip over to SolidWorks. I know you guys have been sitting through PowerPoints for the last 2 days, so I like to show some live stuff to hopefully make it somewhat more interesting. But here's my part. You look underneath, or you look at the geometry a little bit more, you can see some geometry here on the side. Underneath we have a little lip right here. So we got some somewhat complex. You'd probably, I know I'd look at this and sort of wonder if there's an easier way to do it in terms of the actual part design to avoid some of the complex slides that you'd have to put in, but it is what it is, so we're going to walk through that. So I'll flip back here to my PowerPoint to show the just the basic tools as they are, the basic workflow. Pretty much on the Mold Tools toolbar, we're working from left to right, starting with the parting line tool, and that just essentially is defining on the part the interface between positive and negative draft. And so on a part like that, it's fairly simple. It's just a housing with a straight flat. But we might get something a little bit more complex, like this sort of amorphous shape. And so that parting line represents, that interface between where the draft is one way and the other way, and it's just a line around the part. So if I switch back here to my SolidWorks window, I can go ahead and find the Mold Tools toolbar on the Command Manager. And there's a lot of surfacing tools on here, just the stuff that by default SolidWorks has put on here to aid in the mold design. We got surfaces and some analysis tool about our part geometry. But what we focus on is basically these 6 icons, and more specifically these 5. And so the first option here that we're going to start with is our parting line tool. I'll just click on it. It gives us an option to do a draft analysis. We have a draft analysis, separate draft analysis tool in SolidWorks, but this one sort of combines it, so you can also check your draft, but also put the parting line in it at the same time. Now, if I can back up here, like the actual real-world application of these mold tools, what I would do is make a separate SolidWorks configuration and add a scale to account for shrinkage. But I'm just going right into it, assuming that that's already been done. So I can select any flat surface that's going to be my direction of pull, meaning the direction my mold opens, or any reference plane that's going to be that same direction. I click on that, and it has an angle that I can use as my criteria for analyzing it. So I'll hit my draft analysis tool, and it gives us a face classification in the graphics area that I can tell which is positive, which is negative, which might need work to meet the criteria I've entered in on the angles right here. If we look down here, I have selections right here that it will automatically try to select the edge that it finds as the parting line. If it doesn't find it, that's okay, because we can actually come back and select it, and there's a few tricks on how that does that. I'm going to right-click just to clear the selection, just to show you just some few things that you can, just selection tools. If I select one edge, it has it over there on the right here in the parting line, but in the graphics area you see an arrow that I can come over here, and it's just showing the arrow which is the next selection. So I have this icon right here that says add the next selection So I click on it, you see it selects the next one. I can also, there's hotkeys set up. If I hit Y, that means yes. If I hit N, that means next or no. And you can see N toggles to the next edge on the part. So I'm going to hit Y, Y. It's just sort of a shortcut, you know. It's always nice to know where some shortcuts are here and there. So with that selected, I hit the checkbox or the check mark, and I have my parting line. That's the first option. Sometimes, just to show you a little bit more about what you can go into on that parting surface, I'm going to go ahead and open up this other part that I had in the preview. This sort of like amorphous shape that we're trying to fit a parting line. So of course I can pre-select a plane that represents my pole direction. I can hit the parting line surface, hit my draft analysis, and you'll see it picks the top is a positive draft. I rotate it around, it's a negative draft. But in the middle there's this blue line. That just means that that surface sort of splits that the parting line is, or the draft is negative and positive on that surface, both on that surface, which is okay. Over here on the left side in the property manager, we can hit split faces, and it'll split those faces into two faces, and I can go ahead and then manually select that edge, which in this case is just that one edge, and then that lets me go ahead and make my parting line. And so that brings us now here to the next tool on the toolbar, which is the shutoff. Now, in SolidWorks mold tools, we refer to shutoffs as any hole in the part that's going to be formed by metal on metal, contact, making that hole there. And so that's what this shutoff tool does. It's an automated tool to find those shutoffs and allow us to define those. So on this particular part, I have all these edges are going to represent shutoffs. If I go further, it can be a sort of an oddball shape like that. So on this part, I'll go ahead and run that shutoff tool. It's right here on the toolbar. Click on it, and it'll analyze the geometry and try to pre-select those edges, which will be the shutoff edges. And sometimes it picks it good depending on your geometry. Sometimes it doesn't select anything. That's why we can always come back and modify that. Right now, like for example, pick the bottom of that hole. We might want to have it on the other side, just depending on how we want to make this. I'll leave that where it is right now. Just going to show you this one. It didn't automatically select. I'm going to select it anyway. And you'll notice a couple of things. Over there, it turned green on the property manager. But also, we have these little flags right here on each of these edges that it's selected. And that's the way we can control how that surface is on the how that surface is on that for that shutoff surface. The way that works is on the property manager we have sort of a global setting. You have 3 patch types. One is no fill. That assumes, and I got a great example here later on, that assumes that we're going to come back and create and manage those surfaces on our own down the road. On the next one is contact, which is the one that it's selected here by default, and then of course the last one is tangent. And there's certain controls for that. If I select tangent, it tries to pick one of the faces that it intersects and makes it tangent to that face. And there's controls for up or down or which face we're going to work with. If we want to have localized control over that, like let's say this one, we can just click on the flag and it'll change to the next one here. I guess double click, and that made it tangent. And it made it tangent to that bottom face, which is under there. If I select on that arrow, it switches the tangency to the upper face, and it sort of domes it out. We want that to be, if I can select on it. There we go, no fill. They're contact. We want that to say contact. I hit the green checkbox, and there's my surface. Essentially what's happening in the background that you don't essentially see right off the bat is once you put in a shutoff surface, is that it puts in your feature tree, it actually puts a folder there. And that folder is your surface bodies folder. Puts a couple of subfolders in there, one for cavity, one for core. It's easy to just preview what's going on. If I right-click on this, there's an option for isolate. This is a really good tool to use when you're working with multi-body parts or assemblies. It's just a great way to isolate one body or a couple of bodies at a time. So I click on that, it'll just isolate that cavity surface. And I can exit isolate. I actually selected the main one. Here we go, isolate. So you can see that's going to sort of represent my cavity in there. And then of course I can isolate, that's my core, or B side, my B core. So you can start to see some of our geometry take shape. Now these are just surfaces that represent that. We're going to go into the next step, and that is our parting surface. That represents, of course, the parting faces of the mold as they go around the part. So here's what that sort of looks like. I'm going to come back here to SolidWorks, of course, and then click on the parting surfaces icon. And here it brings us to this property manager, and we have a few choices. We'll just focus on this perpendicular to pole one for now. I can touch on that later, but basically these just control how that parting surface is going to look compared to the geometry of the part. You have some controls on how to work that. Perpendicular to pole pretty much means that you have the direction that the mold's going to open, and your surface is going to be perpendicular to that. So in a part like this that has just a straight parting line, it is just going to be a flat face. And so I'll just put some distance on here. I'll make it 2.5 inches and hit OK on my green check mark. And there we go. There's my parting surface. Once again, we look up here in the surface bodies folder. We have another subfolder called the surface bodies, parting surface bodies, which of course represent, if I isolate that, there's our parting surface. And so our next step in the workflow process of the mold tools is our tooling split. And this is where we actually start to see some of our solid geometry take place. And so with that, I'll flip over here to the SolidWorks. Now this is something that's sketch-based, so we'd actually start a sketch and to get into that. So if I click here, it prompts me to pick a plane, a face. In this case, I can select this flat face. I'll view normal to this, sort of the normal I'm used to looking at it with. And I'll go to my rectangle tool, sketch with my center line. I'm going to make that snap that to the midpoint and make it horizontal. That makes this X and Y distance, or the vertical distance, or this distance right here, symmetric. Maybe add a 2.5 right here, make that 8. Let's make that 8.5, give us some room here for, oops. And then of course we'll make that 4.5. And you notice where the sketch is, it's lying inside of that parting surface. And that's sort of required, and I say that with an asterisk, that's required for the tooling split to work. There's an exception to that, which I'll get into a little bit, where it can be outside of that. That's if we're using an interlock. But for now, we're just gonna keep it inside the boundary. And with that, I'll come back and exit the sketch, and it brings me right to the tooling split. And This will give me the option, of course, to define my thickness of my inserts. Make 1.5 inches, well, maybe 2 inches. So we got 2 inches by 1 inch, and then now we have some geometry, some solid geometry. At this point, I like to hide all the stuff that I don't need to see right now. We're pretty much done with these surfaces. We can hide those. And so I can right click, hide that, and then of course it brings this big ugly blue line for our parting line, which was useful earlier, but we don't need it now, so I'll hide that as well. And now as I isolate this, each body you can see I have a core, or cavity. And then I isolate this one and have a core again. There we go. And so we're not quite done, because if we look at our cavity, we of course got some geometry that's not really accessible. It's going to stick right there on the A side, and if we leave it that way. So comes to our next handy tool in our mold tools is our core, and that allows us to easily create side cores. And you can see that's a sketch-driven feature, and we can also use it for lifter pins and core pins, and I even use it to define some ejector pin geometry. So just to show you real quickly how that works, I'm going to use this isolate command again, just by right-clicking on the solid body, going to isolate, and I can pull this up here so it's not in my way. And I'll go to like a wireframe view, so I can select on this front plane and start a sketch. I'm going to do these side cores, and I'll start with my mouse gestures to drag a rectangle, and I'm hoping it didn't snap a line. Oh, snapped a coincident right there. I can select on these lines. I'm going to put a little draft on that to pull that at sort of an angle, maybe add some dimensions. Once again, I hold down Shift and select arcs. I can pull it to the minimum of the arc, and we'll just take that at 1/16 of an inch. I can make this symmetric, so if I hover over and grab that midpoint, I can grab the midpoint of there and make it vertical, and of course add a symmetric relation, and make that another 1/16 of an inch with, let's go 20 degrees, so it's 10 degrees on each side. This doesn't have to be fully defined, but I'll just drag that up to fully define it. And now that I have a closed sketch, I can exit the sketch, hit the core tool, and all I have to do is drag that past the next geometry, or the next entity, the next geometry. Once I do that, I hit the green check mark, and there's my core. It's always easier for me to look and see things in 3D solid, so I'll pull it back to 3D solid, and it's easy to make this second core because I can just start a sketch, select that face. Using my mouse gesture wheel, I can come up and convert the entities, exit the sketch, and make my other side. And you'll notice when you're doing the core tool, it goes transparent, so you can see through and see where you're dragging your core to. So that'll work for that. And now I have my geometry for my side poles there. I can do the same thing for these core pins right here. I'll start a sketch on top, come in, zoom over here to these faces here, and I can go to my convert entities, and I'll just drag, make a multiple profile sketch. As I accept this, exit my sketch, come back to the core tool, and I can drag that below the extents of the geometry, hit the green checkbox, and there I have core pins. Now let's focus on down here. We have a little geometry. Let me isolate this. You have some geometry here that's undercut. So we want to make a lifter pin that'll push that out at an angle so we can pull this part off the mold. To do that, I'm just going to go to my front view of the part, come over to my, I guess it's the front plane, start a sketch, and now I can go to my rectangle tool. Here's a handy just SolidWorks sketching tip I learned last year. You're in the rectangle tool or the circle tool. You can toggle through each of these options by hitting the A key. Just a gee whiz. I don't know if you do much sketching, but all these little secrets. So I got this angled, I can put this angled rectangle and define, you know, just like give it an angle, maybe throw it in as a 1/2 inch. I'm going to constrain it because I have this little edge that it made around the side. I can constrain that point. I just did a point tool, make it a pierce relation, and then of course, let's go back to my view here. Make that coincident. And now I got my sketch here for my lifter pin. Hit the core tool, and over here I can actually enter a blind depth instead of pulling it through the part. So I'll just go a 1/4 inch on both sides to make it an even 1/2 inch. And right here, it didn't select a body, but I can manually select a body in case it's not there, in case there's no selection there. And once I do that, it gives you a preview of the lifter pin. And of course, if I need to, I can come back here and move that face. There's a command called move face. If I right click on a face, expand the right click menu, and right here under face, an option for move. And I can just offset that. I'll just offset that down here. Bring that down as far as I need to. And so there's my lifter pin. So you got quite a few options. You know, ejector pins would be about the same thing. You'd have a sketch and you'd locate that if you're using it for that purpose. So that's the basic workflow of a simple workflow for mold tools, using mold tools. One of the enhancements that they made in recent years, I believe it was last year, is just like in assembly mode, we now have a multi-body part explode. So this is really handy for actually showing off your tooling split, or you know your multi-body inserts, you know, your tooling split and all that. I'll just really show you how that works and where that's at. I'm going to exit my isolate here, and I have my inserts and all the bodies there. And it's located at the same place it is on the assembly, in the assembly mode. If I come over to the configuration tab, I right click on the configuration, and there's an option now for a new exploded view, and it works exactly the same way. In fact, on this, it's exactly the same. I'm going to select my bodies, these core pins, these side pins, and now I can hit this auto space after solid bodies after drag. And what that means is when I drag it up, it'll just auto space the bodies, so I don't have to do multiple steps. Same command is in assemblies if you're working with large assemblies or exploded assemblies. Of course, I can always come back and select this, and you have these little arrows that I can pull and drag to where I need to and where I want to. And oops. And once I'm done with that, I can select another body here. I'll select my part. See if I can select that arrow right here. And of course, my lifter. If I want to show that going up the angle, there's a field right here for the direction. It's defaulting to like Z. If I select an edge, I can drag it up, and there I go. There's my exploded solid body part. So if I want to collapse it, once again, right click on it, collapse, and there we go. And yeah, it didn't all the way collapse. I'm hitting the rebuild here just to make it. Usually it should collapse all the way. So that's a really handy tool if you're working with multi-body parts, especially these tooling splits after you get all these solid bodies. We're going to talk about that surface, the parting surface and the options on there. We had 3 options as we went to it. A tangent to surface, normal to surface, and perpendicular to pole. I probably can come back here and edit my parting surface just to show you where they're at. These 3 options right here. So basically the difference between the 3 is you got this tangent to surface. And this is if you're having something like this. This is one of the example parts I'll be showing here later. Is our direction is up and down, but it has an angled face that's the bottom face. This is an electrical, or no, it's sort of a housing of some sort. And what that means, the tangent to surface is essentially tangent to that surface which is most parallel to your parting line. And so this is the bottom surface there, and it's going to try to make it tangent. And we have a normal to surface, which means normal to that perpendicular surface that's coming down. And so on the part I just showed you, if I hit that normal to surface, it takes this, I think that's about a 2 or 3 degree draft around the outside perimeter of the part, and that's going to be normal to that face. There's also some other options on it. If I just took a block, which I did in this one, and extrude it with a draft angle, and hit that normal to surface, there's 2 faces, because you have it's sort of like that, as you can see right there. And so there's an option, reverse alignment right there. If I click on that, it flips which one is the tangent. And then of course we get to this perpendicular to pole, which I explained earlier is that you have the mold opening direction, and it makes the surface, that surface, parting surface, perpendicular to that. And so there's a few options. One they introduced a couple of years ago. This is sort of an example of how that's going perpendicular to pole. We have that pole straight up and down. 2 years ago, I think it was SolidWorks 2011, they added some new feature that lets you do a manual, sort of a manual mode to it, which lets you control a little bit of how, if you have these little if you have a little bit more complex parting line, that you can control how that parting surface comes off the part. And just to show you, for example, I got a good example right here. Got this part, has a little cutout right there, and then you look over here, you have this geometry right here. Well, obviously your parting line is going to have to come up and over here. So if I come over to my tree, I can go ahead and unsuppress my parting line. You can see I got this parting line all selected. And then we go to my parting surface because I don't need any shutoff surfaces. And if I type in like 1 inch, I got the perpendicular to pole selected, and it defaults to this sort of weird, I don't know if you can see it, should be able to see it right here, how that comes off. We want to be able to control that because we might want to control what angle that this surface geometry is coming off the part. So if I scroll down here, I have this manual mode, and it gives me little handles around here that I can now control. They usually snap to certain areas along this this little rectangle you see out on the extents. And what those snap points are usually, it's going to be, here we go, coincident with that line that it's coming off, or it's going to be coincident with like the X and Y coordinates of their parts. So it's really easy to control that surface with these tools here. So they snap it right there. Another enhancement is you might have some geometry right here where it doesn't quite fill in anything. So you have a start fill section, and you can actually fill this in, end fill surface region, and it'll fill a little notch out like that. Fills it in real nicely that you can go ahead. And then your resulting parting surface has a little bit more control to it. It's a really nice enhancement that that they've put in. I guess it was 2 years ago, yeah. And so we get nice results there. And so now we've gone through most of the tools, and we can look and see SolidWorks has on their knowledge base, if you have access to that, sort of a checklist that you can go through if your tooling split doesn't work. I don't know how many people have ever gone through all that whole process I went through, and you go to the tooling split and it gives you an error message. Well, this is some of the stuff to look for in those situations. First thing is your geometry itself. You know, a lot of downstream or anytime you're importing geometry, if you come in from like an IGESTAT, Parasolid, sometimes you might get geometry that's off, faces that are off. A good way to check for that is the import diagnostics. I used to work tech support at a reseller, and I had issues come across where the tooling split wouldn't work. They go through the whole process, it wouldn't work. And the guy sent me his part, and he had a imported body with 20 some odd features down the tree to modify that. Unfortunately, that import diagnostics only comes up when you have just the imported body. And I got it to work, but I had to delete all those features that he had added. And I did the import diagnostics, got a good geometry, got a good tooling split based on that geometry. So that's something to watch for. If you deal a lot with imported geometry, I would advise importing it, hitting the import diagnostics, and letting it repair, because sometimes down the road, this is in general, anything you're doing in SolidWorks, from FEA to plastics, the SolidWorks plastic simulation to even machining. Anytime you're using those surfaces, you might run into issues if your faces if your model's not well. So we have some tools there. You can do a tools check on your SolidWorks geometry, and that does affect your tooling split. Next thing is, of course, we went through this closed shutoff profiles. You just make sure that all your shutoff geometry's there, and you have faces there. The next one is, you'll see this message. Either if you don't have shutoffs on your part, you'll see it in your parting line property manager. If you have shutoffs, you'll see that just at the top of your property manager of the shutoffs. That's just a way to tell you that, hey, everything's there. You should be able to go ahead and separate it into the core and cavity. And I showed this earlier. You're going to have 3 surface bodies, folders, a cavity, a core, and a parting line. And those should be there. And there's an interesting thing about these is, this is a rule of thumb I always go by is that if you have a shutoff surface and a parting surface, and you take those and you knit them, and it's successful, then it should work. Just a way to check that. And I'll show you a couple of examples where we can check that. And of course, we have our tooling split sketch, and it should be smaller inside the boundary of our parting face, or our parting surface. And that's said with an asterisk, because if we use the interlock option, you can have it outside, and it'll build up material up to that parting surface. And once again, I'll show you that here in a second. And then the tooling split block height should be more. You can see that you need to be past your core, past your cavity. And as long as you have that there, it should work. And I say that knocking on wood, but it should work. Those are the things you'd first check on. And if you check through that whole checklist and it's still not working right, give your reseller a call and make sure they help you out. Now I got a couple examples to go through some fairly complex. We went through sort of a simple example. We're going to get a little bit more complex and a lot of the features that you might run into as you're designing molds for real parts. So this is something I made for someone a few years ago. I modified it so it doesn't look exactly like their part, but some of the same features are on it. And you can see we got a little clip right there that sort of has an undercut where you build up material to clip onto something, and also some like foam or wall mount geometry. This is sort of the close-up of that and how that shut-off tool works. And then we'll go into some more manually creating parting surfaces of odd-shaped geometry, and also show like more of a complex parting line that we might, or parting surface that we might encounter, which then turns into an interlock, the interlock option that we can use to work with, to get it to work. And so for these parts, and let's see, where's that at? Right here. I got a couple of ways I did this part, just as an example. This first one, you can see the geometry is such that we have this little clip, and it has sort of an undercut, so we build up material to make that undercut that comes up from the other side. Of course, there's an angle in there, so you're not grinding on your faces when you're opening and closing your mold. So let's see, I'll go to my feature tree, and I have sort of, I'm a little bit rolled back on my tree to show you the options. Of course, I have a parting line which goes around the perimeter if I highlight on it. I got my shut-off surfaces, which are of course hidden, so as I show these you can see how that ended up. And just to show you how I selected these, I'm going to go ahead and edit this feature and hit the clear selection, so it just knocks those out, and just show you how I selected this. And once again, like I showed you the first parting surface or parting line tool, if I select an edge, it gives me that red arrow and this sort of that dialog box, which I can select and toggle through, hitting my Y key and my N key. And so sometimes, and you can work that, or you can actually manually select it, just going edge by edge. So you have a few options. And so I'm hitting N to flip that arrow and Y to accept it on my keyboard. And you can see once I selected it, it's doing a contact surface. And this is a really handy application for the tangent surface, because all these faces, if it's tangent to it, it sort of gives us the geometry we're looking for. And I'll show you that here. I hit the button there, and it still doesn't look right, but the arrow's flipped the other way. When I flip it to the right direction, you can see it sort of builds up the material the way we want it, the way we would imagine it being. And so that's one way. I just meaning to hit the cancel, so it brings back all my selections. I do something similar to these edges right here. So that's one way to do the parting surface. We'll come back to another way I do that parting surface, but since we're on this part, shut-off surface. We'll come back to the shut-off surface on this part again. But I want to touch on the parting surface and how I did this. This is more of a complex, and what makes it complex is all this geometry right here. The typical parting surface commands. Once again, if I go to this view, you can see the direction of pull is straight up, but because of the way the geometry is we have to come off the part at sort of tangent to that. And I use the tangent to surface selection in the parting tool. But using that, I don't quite get the control around these faces because it just does whatever. So I have to use some surfacing tools. I first knit a couple of surfaces. I knit everything around here. I delete a surface because it came off of this edge. I trim that. I loft to fill that in. I lofted that surface. I did another trim somewhere. I think it was over here. Knitted that. Maybe made an extra surface here, and then of course trimmed that. So there's some things you might have to do if you have a little bit more complex parting line, using some of the surfacing tools to get your geometry the way you need it. And then of course one of the rules that I need to mention as I go through this is back up in here, our surface bodies folder, you want to make sure that your parting surface is inside that parting surfaces folder. So if I select that, just drag it in. Just click on it and drag it into the folder. And there you go. So that's one way. I want to switch back and open up another version of this part to sort of show a different way I've done that. And the first thing I did is, of course, do a parting line. This is a parting line. And I'll just edit the definition just to show you some of the options I have selected. And this is the default options as you insert this in. Because if it's the first one that you're doing, there's a use for core cavity split. And once I have that, I'll just turn it off, and you'll see I have 5 more parting lines in this, or even a 6th parting line right down here. No, wait, 4. I deleted one. Anyway, 4 more parting lines, and then a 5th one down here. I can use a parting line to define my shutoff edges. And that just works the same way. The only difference is that I don't have that use for core cavity split. And then when I do my shutoff surfaces, instead of going in and selecting those edges, I just select the parting lines. And you have the same options, the same control, tangent, fill, no fill, or what was the other one? Anyway, but the interesting thing on this parting line, or in this parting surface, is what I did is I created a parting surface, and you can see this little purple line. I ended it right before all this messy geometry right here. Of course, that's not normal. It gives you a warning message, but it still lets you proceed. So if you can live with a warning message in your tree, that's why it's there, because it's not a closed entity, but you can still use it to do a parting surface. Remember that option in the first one was used for core cavity split, not for parting line. So if I use that for my parting surface, I can use that as my parting surface, tangent to surface again, and it just takes care of all this geometry around the side. I'll turn this part around right here so we can see it. So it takes care, it does a nice job on this. And then I do a boundary surface. Boundary surface is a handy tool if you're using it for anything surface modeling. I use it quite a bit. And what that essentially is a way to, it's like a glorified loft where you can actually use more than one control for the directions. And in this case, I selected these edges around the top as one direction. Here, I'll just edit that so you can see that edge, and it's an open group, so I did a selection manager and selected all those edges. And then for down here, I just selected these surfaces, and that got me that nice straight surface. Hit my surface extrude, which I take a sketch from that flat face, extrude it up, give it some angle geometry, or put a draft on it, and trim them up. Then I knitted them together into one surface body, and then I'm ready to do my tooling split. And as you see the way I did my tooling split, I'll just show you, first of all, I'll show you the, let's see. As I edit the features, not the one I want. Well, as I highlight the sketch, you can see the sketch is outside of the parting surface. You guys can see that. And it allows me to do a tooling split because I have the option interlock surface. And the sketch is actually below this surface on a different plane. And what it does is just builds up material up to that interlock. And it gets me a nice interlock surface. So that's a handy tool depending on your geometry that you're doing if you have a real complex parting line. And so here, I'll show you the next example I have on the list of examples is after you do the tooling split and all the mold tools, you might still need to make further modifications to your geometry in terms of edits and whatnot to get the actual inserts you're going to work with. And so I'm going to do like a splitting the body to get separate bodies and use some tools and surfacing and other things to do that split. So I got a basket type part that's going to flower pot out on some angled pins. And so there's some things I can do with the parting surface. And we're going to split that body and then split it again to have 4 separate parts that I can use as inserts. So we'll go ahead and open my part here and we'll run through the mold tools. I got the parting line tool I'm going to go hit. My draft analysis, it picks the right edge I'm looking at. Now we hit my shut-off tools. And we want this to more or less be, at least these 4 shut-offs to be tangent. So I'll go ahead and just click on these flags. And most of them do the nice tangent, and that makes just a nice cylindrical surface, except for this first one I have to, for some reason, this one loop forces me to flip that arrow. Once I do that, it's ready to move ahead to my parting surface, and I'll go ahead and pull that out to about 2.5 inches. And with my parting surface made, I can do another thing. This is another little handy trick. It's just doing the surface off that circle, so of course it results in a circle, but I want to sort of make the extents of my insert go past that maybe and do a square. I can come to my surfacing tool, my surfacing toolbar, and there's this handy tool called untrim surface. If I select on that edge, it just untrims it back to a square. Of course, any operation I do on these surface tool on these parting surfaces, it sometimes will drag that out of the surface bodies. So I'll click on that and I'll click and drag that here. Now I'm ready for my tooling split. I'll start a sketch on the top face. Let's view normal to it on the top. Drag here. Let me place some, this is something neat of 2013 on the sketches. Let's say I make this 7 inches, tab to my next one, hit 7. It automatically places an equal relation, just puts 1 dimension. So it links that, essentially. I'll exit that and go ahead to my tooling split. And this way, and this here I'll, of course, add my distances for my inserts. And I'm good to go there, except for I want to go ahead and, let's hide these. I want to go ahead and, now I can make that, those side poles. So I'm going to go ahead and isolate this. And let's hide my parting line. I'll just start a SolidWorks sketch on this face it's going to be a circle. Bring this out to like, 6 inches. And this is just going to be 5 inches. There we go. I'll bring that out there, and I'll just use this surface extrude, and I'll extrude up to just a point right there, and I'll put a draft on it of like 10 degrees. And a tool right here is called cap end. What that does is you extrude it a certain distance, and it caps the end in one surface. And so with that, I have a cone with a cap on it that I can then use to my insert features split, cut the part, keep my bodies there, and then I'll exit my isolate, grab this center part and isolate it. start a sketch on it. And then I can draw in my geometry for further splitting. There we go. And then use that same split tool command with that sketch. My recent command, split, cut part, and there I have my 4 bodies that I'll put on angled pins to flower pot out to get that little basket off the mold, off that core. Okay, that's just one way to do it. I forgot, I went to this example too fast, so I forgot to get over to some of my my shutoff example I mentioned in my slides. So backing up, this one goes real quick. It's how we use that no fill command. So I have a parting line and then my shutoff surface. And on my shutoff surface, real quick, I use the no fill. You can see it says no fill. And what that does is assume I'm going to come back to this geometry and create that surface. So real quickly, what it does is I built up a boundary surface. I extended it. I just did surface modeling to get me my geometry I wanted, knit it together, and then the next and the way that works in the mold tools in the cavity core surfaces is I have to have one for each. So I take that and did a surface offset with 0. I type in 0 and it essentially just copies the surface. And so after copying both of those, I come over here and I have to drag those, one into cavity and one into core. And technically you don't have to knit those, you just have to be sure that they are knittable. So you have to knit, you'll be able to knit them together. And there's no gaps big enough to mess that up. I did the same thing here sort of. On this I used a ruled surface, brought that up at a desired angle. And since that is straight, I came back with some lofts to sort of merge those. And then of course, filled it in, knitted it, offset it, and before I can part it, I click and drag those back into the core and cavity components. And now I'm ready to do my parting surface and so on. So the next part is we're showing what's new. I mean, just to show one of the things that might be cool, might be useful for mold designers if you ever get parts that maybe somebody's taken the initiative and made their mold, and your job is to make it. But you want to verify and validate that the geometry they gave you for their inserts might be correct, or you might want to see what you're going to make. And so this is the intersect tool has a few good uses, or some good uses to it. And in mold design, we might use it to reverse engineer geometry to get back to the part. So we can take that and actually get back to the part. So just to show you how that works real quick. Where is that at? Right here. So I've taken this just so you can see what I've been given. I exploded it. I'm going to go ahead and collapse it. And these are imported bodies. This was taken in from another CAD system. And I don't have any control over the geometry to untool split it. But I can go to Insert, Features, Intersect, select each of the solid bodies, click on this Intersect tool, and it gives me my region list, and it actually gives me a 4th region to work with, and that's sort of the empty cavity that's inside there. So now I can select on these inserts, and when I accept that, I'm back to my original part. Just a way to go back and forth. And maybe that's just one step. Once you get your tooling split, you don't want to roll back up in your tree, or just depending on what you're given. Maybe somebody just, who knows how people manipulate the software to get the geometry for the tooling split, or for the core and cavity. So this is a way to get back to that original state. Now we're going to go through sort of electrode design, and there's certainly there's a good third-party partner that does this. I happen to work for that company. I'm not going to show that part off, but it really automates the design. If you're interested, come stop by our booth there at the Geometric Camworks booth. We'll show you a good automated tool. But SolidWorks, you definitely have the tools to work with Electrode design. This product's called Electrode Works. But I'm going to show you SolidWorks core functionality. This is something you guys who are using SolidWorks, you have the access to use. And it's basically a way to make electrodes. How many people use electrodes and design for your EDM, plunge EDM? So this is just a way of using the intersect tool. It's a handy tool for product design, but it's also great for electrode design. And so I'm going to go through that, just the process of working with that, making a separate solid body, and then using the intersect tool to get this geometry. So come in here, I got a part here, and I want to clean up the geometry right here. This is a flat straight edge. I can't really quite get it with my end mills on my machine, so I want to come back and burn that geometry out and get a nice sharp edge. And I got a sketch here. I'll go ahead and hit my normal extrude tool. And making it simple, I'll just grab that out and make sure the bottom goes past the bottom of the part. And the important part of doing this is you just want to make sure that you uncheck this merge result. So the result is two separate solid bodies. And it'll look like that. You'll see a different line than you would if you had that checked. And obviously in your solid bodies folder, you would see a boss extrude. Now we're going to come to our intersect tool. It's insert features. Not intersect, I'm sorry, the indent tool. I might have said intersect earlier, I meant indent. And we have some options here. We'll hit the target body. That means the body that I'm going to keep, and the other one I'm going to cut away with. And that's what my tool body region is. And what I want to do is I want to select this cut, and what that does is just take away from this body, take away the geometry of the other body. But we have some other options in here. There's an offset option, and if we want to account for our overburn, we can enter in a value and it'll offset that 3 thousandths, all these faces. And so now we have an electrode here with an offset surface. Now of course we have these little overhanging faces. We want to move those back maybe. So I'll just isolate this face. Control select these faces, right click, and in this right click menu there's this option for move. We've used it earlier. I'll offset that. Oh, not 25, I meant 250. And we'll reverse that. And now that moves back. We can see how that'll look in the final thing. There's our geometry for our electrode. And so we're good to go in that regard. And so now I've gone through pretty much the mold tools and how to use them. I'm going to spend the rest of the time sort of taking it to the next level and going through the actual mold-based design, taking what we have now and putting it into a mold-based, designing it, assuming that you guys have already done all the mathematics and picked out the size you're going to work with. All I'm going to show is just some options of where to get a mold base from. Most mold tooling companies that like DME or PCS or whatever. I said that right. Anyway, anybody that can supply a mold base probably has geometry, and if they don't, the other ones that do have the SolidWorks geometry that you can get, they probably have that geometry that they make. It's almost a standard from what I've seen. And anything that's like any mold component, we've had, the model train company, we had one complex mold we did inserts for that had side pulls on the sides and the ends. And those standard inserts for those side core pulls are also standard. We got CAD models for those that we could use. So any component that you can use, it's there. A lot of it can be even on 3D Content Central. A common one is, of course, DME. How many people have downloaded off DME any CAD model? yeah, it's a great resource. It's actually pretty fun to watch. At least, you know, they give you a macro. You run it, you watch your build the mold base. It's sort of fun. I wish I had time right now to show it because it takes a few minutes, and sometimes it takes longer than other times that I have time limitations. Another option here, of course, is 3D Content Central. I actually have this one loaded here. You can select, you know, your mold size, and then you got this is I think this is one of the mold-based companies, and it looks like it's bogging down on me here. But you have right here options to pick out the size you want, and it builds up, gives you a good preview of what you're working with. There we go. I was just building this 7x7 or 8x8 mold size. But you have, of course, options to, oops, looks like it's not letting me drag that around. You pick size you're working with, your dimensions of your A and your B plate, and the various other sizes. You can hit update preview, it updates it for you. DME does sort of the same thing. And I don't know what other, I haven't had to grab a mold base off other sites for a while, but I'm sure there might be something similar on the other suppliers. But either way, you get solid geometry from them. It's nice, you don't have to build that up. The only potential downside is there might be a better way to organize that assembly. The ones I've downloaded just sort of have an assembly and all the parts in the tree. And so I've sort of gone through of using probably best practice, or what I think might be the best way. I'm not saying my way is the best way, but I thought it was a good way to organize your assembly to be able to use it. So basically what I do is I take it and make sub-assemblies, and then take it one step further, make display states to hide and show what I'm working with when I'm putting things in the assembly. So just in the 20 minutes here I have left, I'll just go through a simple, hopefully I have enough time to explain this thoroughly in 20 minutes because it can get quite complicated when it comes to designing. But this is a raw mold base from DME. I've just finished playing the macro, saved the file, and it just creates my plates, and it's all, you can see right here, it's all in my tree. Just a bunch of parts. Might be hard to manage, and if you're placing inserts in there, ejector pins and whatnot. So what I can do is, what I like to do, oops, I hit the wrong button and closed my part here. What I like to do is I'll start with my A side assembly, and I can real easily see my A plate. So I select on it and I can see it in the tree. I'll right click on that, expand the menu, and there's this option here, Form New Sub-Assembly here. If I click on it, it creates what's known as a virtual assembly. An assembly that really doesn't exist anywhere else in like the hard drive or on your computer, but in this assembly. And you can of course save that out as a separate assembly, which you'll obviously do, but beforehand, you can name it real easily. I'll call that A side for now. And I have all these components that are tied to the A side, like these bolts and the sprue bushing and the locator ring and all that. So to be able to, easy way to get everything in there is to, of course, click and drag it. But the way I like to do is I like to hide this assembly. And then I can select on everything else from a left click and drag, or left click and drag from the right to left. That selects all that geometry, or selects all these components. And it also selects them in the tree. So it's done all the selecting for me. I can hold down Control. Of course, if I hit Control and drop, it's going to copy it. But if I let go of Control, it selects all those components. And if I hover over my assembly, it'll place them all in there. One step, nice and easy. And now I can go ahead to my B side. I'll rotate that 90, select on my B plate, do the same thing, right click, form new sub-assembly here, and call this B side. And do the same thing. I'll just hide this. And if you look here, I got these 4 pins. I'm going to make part of the ejector pin assembly because they're tied to the ejector plate. They're return pins and sprue puller. But all this geometry out here, of course, is just, I'll just consider that part of my B side. So I'll do maybe a control select as much geometry as I can. I might have to do this in a couple of stages. Once again, I hold down control, release control, drag and drop over the B side assembly. And it didn't get all the components, but I can still easily drag and drop. And I'm actually moving the components from the main assembly into that sub-assembly. So if let's say I isolate this A assembly, I'm going to right click on the A side assembly, hit isolate. All the components that would be in the A side assembly, meaning if I hung this on my injection press, that's what's tied to the A side. And so that's all there in my B side. And now the remaining components are all anything that has to do with my ejector plate. And I can do just a shift select, right click, and form new sub-assembly here. Of course, call that my ejector plate. And there I go. I got my three components. Might be good practice to, for the most part, these don't move. I'm not testing any like motion type dynamics. I might do that if I'm doing side pulls, but definitely for not the whole thing, at least right now. So I can just fix these. And then, of course, show them. And now the next step is to make display states. And so I can come right here, right-click. I've expanded this area. This is called the display pane. And I can right-click anywhere and add a display state on the fly. And I'll call this my B side. And what I do after I create that is I can come and hide everything else. And that just sort of, that's a way to keep that display state. So I can always come back to just showing that component. You can also make things transparent. You can add different display states based on what you're going to do to this. And so for my B side, I have a display state. If I want to come back and toggle between display states, I can either come to my configuration manager and double click on one of these, or I can easily access it by these 2 arrows. If I right click on it, it brings me my inactive display state list. So I'm going to come back to my original display state and I'm going to add an A side. And of course, at this point, I can hide my other sub-assemblies. And now I have real quick access between my B side and my A side as I'm working with this assembly to bring in all the components that I need to. So that's the way I like to set things up before I get really down and dirty into it. This is where we get this is where we can get some good at some top-down assembly modeling. One step we might want to do if we're using our tooling split for this main assembly to bring that geometry in, there's a few ways we can work with that. And here's one of the ways, is that we can create an assembly on the fly from a multi-body part. There's an option to save bodies. And we can save those out to individual files and create an assembly on the fly. And so if I right-click on the Solid Bodies folder of SolidWorks and click Save Bodies, it'll bring me to a property manager which lets me actually select out individual files and then come down here to create assembly. I click on Create Assembly and it creates a separate assembly based on that. And as a result, I have an assembly file with an A insert, or with my insert in my solid body geometry. You can use this for any time you have a multi-body part. You can easily convert it to an assembly and have individual part files. And once again, this is linked back to your original model. And design changes should propagate back down to this. So the next step, of course, is to take that insert assembly and place it actually into your main assembly, as you can see right here. And I like to use the distance mates, the mates to locate it. And then I delete it and fix my component there, and that just makes it easier for our next step, which is clicking and dragging and dropping those components from your insert assembly into the individual assemblies. And so just to show you how that works, I'll get to that point. I think it's this one. Yeah. So just to show you, I have my insert assembly, everything's fixed. I'm ready to work. I can just move this B insert over to the B side assembly, move any mates that might be associated with it, and do the same thing for the A side. And now I have a B side assembly with its insert located in the correct place. And what I'll do is I copy that around to the other side using a pattern, a circular pattern based off the center axis, and then I cut away in that B plate, just in context, cut in the B plate down to whatever thickness my insert is, and just, you fine tune the geometry based on whatever tolerances you're using and clearance and whatnot. And that's how you basically place it in there. Now we can get a little bit more creative with our ejector pin placement. I was hoping to show all this stuff as a live demo, but I'm running out of time here. So if we create a display state that just shows our ejector plate and our B plate, we can use our whole series to create a hole for our ejector plates. A nice thing about this, and I should have probably mentioned this, is the hole wizard actually has DME standards and other Haskell PCS type, superior type mold tooling standards holes. You'll have a THX ejector pin holes that you can select. And when we're using hole series, we have access to those. And so I have here that we place one hole series per size if we have multiple size ejector pins. So essentially what I did is I hit the hole series, and it's easiest to pre-select your plane and then hit hole series, because that results in a 2D sketch. And the way the hole series works, as opposed to the hole wizard in the individual SolidWorks part file, is it's different. They haven't quite updated it such that you don't have to pre-select. You have to pre-select a plane in the hole series, whereas hole wizard, you can just hit hole wizard and then go off a 2D sketch. But this is different. So it's always best to pre-select your hole, and then you're brought to this property manager. The first tab is essentially your sketch. You place your sketch based on maybe some holes in your insert that you've put for your ejector pins, constraining them, and then you have some options in the hole series to, let's see, I don't have it, I have it right here. You have this second tab sort of is your middle sections, and then the last tab is your end component. Hole series is used for if you're bolting a bunch of plates together, so you have the option between like a threaded hole or a through hole. We hit through hole because we're doing ejector pins, and then we pick that B plate as our end plate. That makes a nice hole. So now we have hole series holes through the parts. And of course we can constrain them to our geometry that's there in the insert for our ejector pins. Now, ejector pins, there might be a better, easier way to do this. I found some advantages using a hole wizard or weldments, using a weldments profiles for it, and there's some neat things. You have to set this up. It doesn't come default to weldments. Weldments is for like structural members. So So it's not really designed for this, so you have to build up a design library of just their library parts. But essentially, you can draw on a 3D sketch. You just draw lines to represent the distance of your ejector pins through those hole series up to the cavity of your part. And then you can come to your hole wizard. I'll just show a little bit more of how that looks. You can use your actual geometry of your part if you insert that into your assembly. So using the weldments tool, a structural member, you insert that and you can actually select those lines and it places an ejector pin. One of the advantages to doing it that way, well, I guess I show beforehand it's a library part. It's essentially you just put them in a certain file in a directory inside that you reference to through your options. And then when you go to Hole Wizard, or when you go to weldments, it'll be on that list. Yeah, I guess I should show this real quickly. I got just a few minutes I wanted to go over. Well, looks like I'm going to run out of time here. Just it's there on the menu here. Right here, you'll see it right here, and you'll have a whole options based on how you have that set up. But the advantage to having that is weldments give you a length, and so if you pull it out enough decimal points, you can get a pretty accurate measurement, assuming your mold stacks up in real life based on your CAD model. And so you have basic lengths, and I've actually added a formula in some cases where it takes it from the parting line. So you have that distance depending on how you want to do it. You can customize that in such a way that you can get a pretty good length. So that's a pretty handy tool, because all you have to do is print out your weldment cut list and give that to your pin grinder person. And so other features in the mold you can finish, finish your runners and your cooling lines. And of course you can use sort of the same techniques of sub-assemblies to do side pulls and various lifter pin type geometry, and get the mold geometry that you want for the rest of the mold. So we've gone through this. There's other techniques to use to create cavities. I wanted to touch on this briefly before I finished, and hopefully get you guys on your way to whatever the event is tonight. But one thing I did, I worked at the model train company. We had just a mud base that we'd do a lot of our components in, and so I had a standard assembly that I'd use. And I found it very useful to just, with that standard assembly, I'd pull it out of a library, save it as a different name, and then I could start working with it. And so one of the ways I'd do it is I'd assemble it, actually put the components into the assembly, and use that assembly to create my geometry. And I'll just show you real quickly how that works. So once again, I have my B side here, and if I edit my part, I assemble it like this. I come back and I edit the B side, and then I start building up geometry. I build up to fill in the core of this part. I use my cavity tool, and then I cut away what I don't need. So I cut away outside here. I have all the internal geometry there based on the cavity. And that's easy to check because you select on the cavity and you can see a highlight of the faces to make sure you got everything that's touching the part. And of course I move these faces out, add some draft, and put a fillet on there. And that gets me my B side. And that gets me this nice notched out face for a shutoff that I can use. And then of course when I go to my A insert, to my A side, I can edit that and go Insert, Features, Cavity, and I can use my B insert as part of the design component and also these plastic parts. So this cavity tool is really handy to use as well, and it's something that would be good to spend some time on in terms of how to manipulate that. That's a great subject. But when I can use that, there's options to scale if I want to. I typically like to scale on the part, make a configuration of the part, scale it up, put it into the assembly, and do this step. So when I hit the green check mark, I got my A side. And everything's based on the B side, so whatever I'm using for shutoffs and parting surfaces there is transferred over to the A side. And so that's typically another way I've been using. I use a lot to design molds. And so there's advantages. We have tools for a whole bunch of tools that SolidWorks gives us to use in our designing. And so I've used a combination of both techniques, depending on the geometry. Sometimes, a lot of times the mold tools gets me the parting surface I need if it's very complex. A lot of times I can just use this technique, depending on what works best. So that's the gist of my presentation. I hope I hope it was exciting. Please fill out the forms, and we like your feedback. And if you have any questions, you can ask them now. Otherwise, I'll be here for a few minutes. So, thank you.